What if I told you that the photons from sun, which are obviously light particles, covers millions of miles in millions of years just to reach to the earth?
Wait,
What are you saying? Our science teacher told us that the sunlight has a speed of 300,000 kilometers per second and takes approximately 8.5 minutes to reach it to the earth? You're teaching us wrong.
FBI, open up!
Hold on, just wait for a few minutes, I will explain it to you. So without wasting any more time, let's dive into the mysteriously old journey of sunlight. The delayed darkness. Have you ever thought about what would happen if the sun were to switch off like a light bulb? Don't worry, we know that it can't happen. However, suppose someone has a universal remote were to click off the power and the sun did go dark. In that case, we wouldn't know about it for almost 8.5 minutes. Wondering why? Well, it's because Earth orbits around the sun at an average speed of 150 million kilometers away, and the light travels at a fastest speed known to us around 300,000 kilometers per second. When we divide the speed by the total distance of Earth, we get 500 seconds, almost 8.5 minutes. Sometimes a little more, sometimes a little less, because our orbit is an actual ellipse, not in a perfect circle. So that's how long it would take before we knew the sun went dark. The mystery of sunlight age, it's older than you think. Did you know that the sunlight we see is actually super old, tens of thousands of years old? That's right. Every photon of sunlight that has ever hit your face was born when woolly mammoths still roamed the earth. Wait, you might ask, isn't it strange that it takes only 8 minutes for a photon to travel the immense distance from the sun's surface to earth? But sunlight is tens of thousands of years old? Let's find out the answer. The complex journey of sunlight. Understanding the process. Light travels in a straight line from the sun to earth. And we know this because we cast a shadow on a sunny day. But a photon's journey out of a sun is not so direct. Every photon of sunlight is born as a byproduct of powerful nuclear reactions in the sun's core as hydrogen nuclei are fused to make helium nuclei. The core of the sun is like billions of hydrogen bombs exploding every second. However, the outward pressure of these immense nuclear reactions is held in by the enormous mass of hot gas, the rest of the sun collapsing under gravity. You can think of the sun as a bomb held in by a gravity shell or a heavy ball of a gas inflated by a nuclear balloon. Every star is a balancing act between the urge to collapse and the urge to explode, which makes it hard for sunlight to escape the sun. So, all these fusion reactions happening in the sun's core release massive amounts of energy in the form of gamma rays. Gamma rays are high energy photons. After a gamma ray of photon is born, it travels in one direction until it collides with some other particles inside the sun and ricochets in other direction. As these photons interact with and ricochets off all the other matter inside the sun, they gradually lose energy and go from gamma rays to X-rays, ultraviolet, infrared, visible light, and finally escape the sun. However, to get to space, each photon has a ricochet its way through the game of nuclear pinball. The random walk of sunlight, the slow and ineffective path to reach Earth. This journey takes a lot longer than the straight path from the core of the surface. It's kind of a random, like a random walk. Imagine someone is going to his home after heavily drinking alcohol. He might take a zigzag path, walk in circles, or even backtrack a few times. The journey of sunlight is similar, except it takes millions of years to reach the surface. But why does it take so long? The answer lies in the properties of materials that makes up the sun's interior. The sun is a plasma, a hot ionized gas consisting of free electrons and positively charged ions. The plasma is so dense that photons, the particles that make up light, cannot travel far before they collide with an ion or electron. Every collision causes the photon to change direction, lose some of its energy. The photons that are generated in the sun's core have a very high energy, which means that they can travel a short distance before colliding with an ion or electron. These collisions cause the photons to scatter in random directions, making their journey to the surface longer and more inefficient. As a result, it can take up to 100,000 years for a photon to reach the surface of the sun. But the journey of photons does not end there. Once a photon reaches the surface, they are released into space where they can continue their journey towards Earth. However, the journey is not over yet. Even in space, the photons can still be scattered by dust particles and other objects, causing them to lose energy and change direction. Despite the slow and inefficient journey of sun, it is still the most important source of energy for life on Earth. Without it, life as we know it would not exist. So the next time you take a sun bath, take a moment to appreciate the long and winding journey that the photons had to take to reach you.